Continuing our 5.6 lesson, we are looking at rationalizing the denominator. Now we've already done that in one of our examples today. We had the y to the fourth over x cubed square root of x. To rationalize the denominator, we wanted to make sure that we got rid of all radicals in the denominator. So in this case, because these were just being multiplied, we could multiply by the square root of x over the square root of x. Again, remembering that it has to be the same number in the numerator and the denominator to make a form of 1. Now when we multiply across, our square root of x times our square root of x just becomes x, and we're still multiplying by our x cubed. In the top there we have y to the fourth times square root of x. From here, simplifying even further, our x times our x cubed becomes x to the fourth, and we still have on top y to the fourth times the square root of x. So this was our final answer for that problem. Notice that we got rid of all of the radicals out of our denominator, which is what we were shooting for. So in that case, because we multiplied everything, we could just multiply by our radical. So when our denominator looks something like this, so 5 plus root 3, remembering that that's all one number, that's one binomial on bottom, you might think right away, oh, we can just multiply by the square root again, like we did in our last one. Well, if we see how that works, we have to distribute it between the two. Square root of 3 times the square root of 3 is 3. Square root of 3 times 5 is 5 square roots of 3. So in this case, you did get rid of this radical here, but now you made a new radical by multiplying by our 5. So just multiplying by the radical is not going to work in these cases. What we need is called the conjugate. And a conjugate is basically whenever we have our binomial or our binomials, normally what we're going to be using, n plus, we'll use an index of a radical and our m underneath. Our conjugate is basically just going to be the same values, but instead of the plus in front of the radical, it's going to be minus. So our conjugate would be n minus our root of m. Now, if they had it written in this form, if they had I root m plus n, our conjugate then, we switch the sign that's in front of the radical to negative I root m plus n. So it's always the sign that's in front of the radical that needs to get switched, because that ensures then that when we multiply it by the original, we'll get rid of all of our radicals. So if we wanted to find our conjugate, let's say we had 1 plus square root of 3, our conjugate would be 1 minus the square root of 3. So to check and be sure that this conjugate voodoo mumbo jumbo actually works, let's try it out. So the conjugate of 5 plus 3, or square roots of 3, is going to be 5 minus the square root of 3. And we're using our bottom one, remember, the denominator, because that's the one that we need to rationalize. Now, anytime that we multiply our fraction here to rationalize it, we need to make sure we're multiplying the same thing on bottom as we are on top. So this also needs to become 5 minus the square root of 3. Once we have it in this form, now we FOIL. So again, we recognize that all of these are individual binomials. In this, on our denominator, in our bottom case, we have 5 times 5 is 25. 5 times negative square root of 3 becomes negative 5 square root of 3. Our square root of 3 times 5 becomes a plus 5 square roots of 3. And our square root of 3 times a negative square root of 3 becomes negative 3. So that's our denominator. If we wanted to simplify that, we can notice that we have a plus 5 square roots of 3 and a minus 5 square roots of 3. Take those out. So we're left with 25 minus 3 is just 22. So our denominator in this case is 22. Now looking at our numerator, when we want to FOIL that out, 1 times 5 is 5. 1 times negative square root of 3, negative square root of 3. Negative square root of 3 times 5 is negative 5 square roots of 3. And negative square root of 3 times negative square root of 3 becomes a positive 3. So in this case, when we combine our terms, we have different amounts of our square root of 3. We have a negative 1 and a negative 5, so that becomes negative 6 square roots of 3. And our 5 and our 3 add to 8. I have it written kind of backwards. Normally you want the constant out front, so we would write that as 8. Oops, not plus, that would be minus 6 square roots of 3. Now at this point, I might say, oh hey, it looks like we're done. But that's when you would chime in with a, hey, Mr. Anderson, what about the greatest common factor? I'd say, oh, you're right. On all of these, we can pull a 2 out. So pulling 2 out of 8 becomes 4. Pulling 2 out of our 6 becomes 3 square roots of 3. And we leave the square root of 3 as it is, because that's essentially it's like our x. It's a number being multiplied together. We can pull the 2 out of the 6, but not out of the square roots of 3. And we can pull a 2 out of our 22, which leaves 11. So in the end, this is our final answer. And good call on the greatest common factor, by the way. Now, applying our same principles to this, we know what we need to do right away. We are looking for our conjugate. So we use our denominator here. We say that it'll be 4 plus square root of 3 instead of 4 minus the square root of 3. And we need to do that on top as well. 4 plus square root of 3 with our parentheses. Now in this case, it doesn't matter if you want to do the denominator or the numerator first. We always just do the numerator, just so we're working from top to bottom. 2 times 4 is 8. 2 times square root of 3 is 2 square roots of 3. Square root of 3 times 4 is 4 square roots of 3. And the square root of 3 times the square root of 3 is 3. Combining like terms, we have our 8 and our 3 make 11. Our 2 square roots of 3 and our 4 square roots of 3 make 6 square roots of 3. So that's going to be our numerator. Looking at our denominator, 4 times 4 is 16. 4 times square root of 3 is 4 square roots of 3. Negative square root of 3 times 4 is, again, minus 4 square roots of 3. And negative square root of 3 times square root of 3 is negative 3. Oops, that's a 3. Again, combining like terms, we notice that we have a square root of 3 term in each of these, and they're plus 4 and minus 4. Those subtract out. So look at that. We got rid of our radicals, which is exactly what we were looking to do. Then we're left with a 16 minus 3, which becomes 13. So in the end, our answer is 11 plus 6 square roots of 3 over 13. And in this case, there is no greatest common factor because you can't divide anything by or out of 11, 13, and 6. So our final answer is right there.